Morning, everybody. This lesson here, I'm going to show you how to solve these problems involving, you're going to calculate resistance in parallel circuits and series circuits. So let's get started here. So what you see on the board there are a couple of schematic diagrams. And you'll see that on the worksheet too, which by the way has already been posted on Google Classroom. So you'll be provided with the voltage information and the resistance values of the resistors that are in this schematic diagram. It's supposed to represent a circuit. Now, in all cases, what you're doing here is you're going to have two answers. First answer is you're going to calculate the total resistance. And the second answer is you're going to calculate the total current using the formula for Ohm's law. So I'll show you that. I'll show you the second part here once we get through the first part. Now, some of you, especially those of you like in certain trades, you may recognize this formula: 1 over R sub 1 plus 1 over R sub 2. For our intents and purposes, in these diagrams, there's only going to be two resistors. Most of you, again, you see this formula, but this formula also works with it. You can also use this as well, where you take the product, you multiply the values of the resistors divided by the sum of the value of the resistors. Either way, you get an answer that they're pretty close. I mean, they're off by maybe 1 or 2 hundredths difference, and that's it. So if you're used to using this formula here, 1 over R sub 1 plus 1 over R sub 2, use that. You can use product over sum as well. Again, it doesn't matter to me. Just show the work and get the correct answer. I mean, at least try it, and if I need to work with you, then no problem. So, given this information here, we have the value of resistor 1 rather is 10. And the value of resistor 2 is 12. So I'm going to use this product over sum formula here. So R sub tot, or tot, I guess, equals 10 times 12 over 10 plus 12. That's supposed to be a times there. So there we go. All right. 10 times 12 is 120. 10 plus 12 is 22. The total resistance then, when you divide 120 by 22, you get 5.45. So this is 5.45 ohms. All right, just to show you that it works this way too, 1 over 10 plus 1 over 12. So it takes a little bit longer on the calculator, but again, if this is what you're used to, then that's fine, of course. So let's see, 1 divided by, oops, did that wrong, that one. That, and then there should be a button on here. Yeah, there it is. Yeah, all right. You still get 5.45. So again, this might be easier for you, or maybe, maybe using this version of the formula. It's fine, either way. Okay, so notice that here in this first example here, these resistors are definitely parallel to each other. All right, we all know, I'm assuming we all know what parallel means. So they're parallel to each other, so you're going to use, again, one of these two formulas here. Now, you also are asked to calculate the current, all right, the total current. So basically, you're going to use Ohm's law, all right. Remember, Ohm's law is R equals V over I. So we're going to say 5.45 equals, this is where the voltage comes in, all right. Notice it's labeled here. We didn't use it at all through here, but we do need to use it when we're calculating Ohm's law. And we have it set up like that. Then again, like I said in the previous video, you cross multiply, or some of you can look at that and say, aha, what I do here is I divide 10 by 5.45. And when you do that, I is going to come out to be 1.83 amps. All right, so you're going to have two answers. First answer, electrical resistance, all right, the total resistance in the circuit. Second answer is going to be calculating the current. All right, now it's going to be the same procedure each time the resistors are in parallel, and that's what you have to watch out for. Just because you see a schematic diagram, whether it's this one or this one, notice these resistors are not parallel to each other. If they're not parallel to each other, you only need to do half of this. All right? So don't think that you got to go through all this each and every time. You still have to calculate total resistance and total current. But with series circuits, it's a little bit easier because all you're going to do here for series circuits is this. You got this formula, R sub tot or tot equals R sub 1 plus R sub 2. Simply add the numbers together. But the catch is, I need you to show work. Don't just say, you see this, oh, 13 plus 7, that's 20. Don't just write R sub tot equals 20. I need to know that you know how to add 13 and 7. So just write down what you type in on your calculator on the paper. Or, type it in the computer is what I meant to say. All right? So just make sure you're showing your work. Don't just give me the answer. That rule is still in effect, and it will be until the end of the school year. Okay, so we have 13 plus 7, which of course is 20. And here's my omegas in there. You don't have to have that in there, but just FYI, just to kind of complete the process here. But then what you want to do is, again, solve for the current. So using Ohm's law again, R equals V over I. All right, we just found out that the resistance is 20. We know that the voltage is 12 because that's provided in the diagram for us, and we're trying to find the current. 12 divided by 20, when it's all said and done, is this, 0.60 amps. All right, so again, two answers. You have two answers there. The first answer, again, you're solving for resistance. The second answer is you're asked to calculate the current. So many students over the years, and I see it every year. Let's not see it this year, where students they stop when they get here. They do a great job figuring out the resistance. Then they just move on, like on the chapter test. You need to calculate the current as well, so please keep that in mind. All right, read the problems carefully. All right, so again, the resistors are parallel here, so we're going to use either this formula or this one. They both come out to the exact same thing. If you don't believe it, don't believe me. I get it. Try it for yourself and see what happens. With resistors that are not parallel, in other words, this is a series circuit, then all you do, add up the values of the resistors. 13 plus 7, 20. All right, and then again, find the total current using Ohm's law, and you'll get that second answer. So no matter what kind of circuit you're focusing on, either it's parallel or series, on the worksheet called Resistance in Parallel and Series Circuits, you're going to have two answers for number one, two answers for number two, so on and so forth. And you'll be asked to, of course, write out the formulas towards the end of the, like the last part of the assignment. And then the last question, I need you to make sure you read the directions carefully. I want you to rearrange the Ohm's law formula so that you solve for I, so that you end up solving for I. So really, what you should have for number 10, all right, on that worksheet is this. When you solve for I, this comes over, all right, those cancel out. I equals, it ends up being V divided by R. All right, I equals V divided by R, because in essence you're taking the voltage and you're dividing it by the resistance in order to get the current. And again, this is just Ohm's law. We go from this to this, just rearranging everything. So take care of this. Remember, watch out for series versus parallel. And as always, if you have questions, let me know. And Get this done before Tuesday at 11:59 p.m.